In this video, we're going to start talking about epsilon delta proofs for limits. And in part 1, we're going to focus in on the scratch work necessary to do before we actually construct our proof. So let's suppose that somebody asks us to prove that the limit as x approaches 2 of 4x subtract 1 is equal to 7. We need to do this in the context of the formal definition of a limit. So let's quickly review what that formal definition says. It says that the limit as x approaches a of f of x is equal to L if there exists for every epsilon greater than 0 a delta greater than 0 such that the absolute value of f of x minus L is less than epsilon whenever 0 is less than the absolute value of x minus a is less than delta. What our scratch work will focus on is finding the relationship between epsilon and delta. So let's go back to our actual limit that we're interested in. What we need to show is that our function, 4x subtract 1, minus the value of our limit, 7, has an absolute value that's smaller than epsilon. So what we need to do is figure out how delta and epsilon are related to each other. So this is what my scratch work is going to look like. I'll start out with the thing that I really need to show. Now I'm going to work on that inequality until I get an inequality of the form x minus a is less than some quantity. So I need a way to transform the absolute value of 4x subtract 1 minus 7 into an absolute value of x subtract 2. So that's going to be the purpose of our scratch work. So here we go. We're actually going to do the scratch work to find the relationship between delta and epsilon. So we start out with what we want to show. Absolute value of 4x subtract 1 subtract 7 is less than epsilon. Now, keep in mind the sort of things I'm allowed to do with absolute values. The first thing I'm going to do is combine any like terms that I see inside of the absolute value symbol. So in this case, I have a -1 and a -7 as like terms, so I'm going to combine them. So now I can write 4x subtract 8 is less than epsilon. I don't want a statement about 4x subtract 8, I want a statement about x subtract 2. So I see that I can factor inside of my absolute value symbols. 4x minus 8 is the same as 4 times the quantity x minus 2. So now I'm much closer to what I want. At this point, I need to be able to get rid of that extra factor of 4. Because 4 is a positive number, I can pull it to the outside of the absolute value. So the absolute value of 4 times x minus 2 is the same as 4 times the absolute value of x subtract 2. So now I'll have what I want if I can get the absolute value of x minus 2 isolated. I see that I'm multiplying, so I know that to undo multiplication I divide. The one thing I really need to watch out for in this case, however, is that I am dealing with an inequality. And in order not to damage the statement, I need to make sure that I'm dividing by only quantities which are positive. Because recall, if you divide an inequality by a negative or multiply by a negative, it changes the direction of the inequality. But 4 is a positive number, so we're all right. So we can say that the absolute value of x minus 2 is less than epsilon divided by 4. So I have gone from a statement about 4x minus 1 subtract 7 to a statement about x subtract 2. Now recall, in order for our definition to work correctly, x minus 2 needs to be less than delta. And now we have our link. I see that here's x minus 2 less than delta. Here's x minus 2 less than epsilon over 4. So that means that as long as delta is smaller than epsilon over 4, my proof will work. So now I have my relationship. Delta is less than or equal to epsilon over 4. And this is the entire point of my scratch work, is to find that relationship. I haven't actually proved anything at this point. I've only figured out something I need to know in order to be able to write my proof. So let's try the scratch work for a second limit. This one asks us to show that the limit as x approaches negative 4 of 5x plus 12 equals negative 8. So I need to discover the relationship between delta and epsilon necessary to prove this fact. So I'm going to do the same thing I did before. In my scratch work, I'm going to start off with 5x plus 12 subtract negative 8 is less than epsilon. And I need to get to a statement about the difference between x and negative 4. So here we go. Same thing as before, I'm going to combine my like terms inside of the absolute value. So 12 subtract negative 8 is 20. I realize I don't want a statement about 5x, I want a statement about x, so I'm going to factor out the 5. And since 5 is a positive number, I can factor it all the way out of the absolute value. And again, because 5 is a positive factor, I can divide by it without changing the direction of my inequality. So I now have the absolute value of x plus 4 is less than epsilon over 5. I need the statement absolute value of x subtract negative 4 is less than delta. But x plus 4 and x subtract negative 4 are the same thing. Therefore, I know that my proof will work as long as delta is less than or equal to epsilon over 5. So here's one for you to try. See if you can find the relationship between delta and epsilon necessary to prove that the limit as x approaches 5 of negative 2x plus 12 is equal to 2. So pause the video, do your scratch work and come up with your relationship, and then restart the video to check your answer. Okay, so let's see how you did. So for our scratch work, we're going to start out by looking at the absolute value of negative 2x plus 12 subtract 2. We claim that that is less than epsilon. Now we're going to combine our like terms. Negative 2x plus 10 has an absolute value less than epsilon. Now I need to come in here and do my factoring. So I can pull out negative 2. So negative 2 times x minus 5 has an absolute value less than epsilon. Now here's where I need to put on my thinking cap just a little bit. When I split this one apart, the negative 2 has a negative sign on it, and I can't factor out negative stuff. However, I can factor out the absolute value of negative 2. So now I can say the absolute value of negative 2 times the absolute value of x minus 5 is less than epsilon. Now that I have this, I realize that the absolute value of negative 2 is really just 2. So I can make that replacement, and that allows me to divide and isolate the x minus 5. So the absolute value of x minus 5 is smaller than epsilon over 2. This means that my proof will work as long as delta is less than or equal to epsilon over 2. And this is the relationship that I would need to write my proof. Now see if you can complete this scratch work to find the relationship between delta and epsilon that you would need to prove that the limit as x approaches negative 4 of 3x plus 1 equals negative 11. Pause the video, do the work, and then restart to check. Okay, so let's take a look at the solution. So I'm going to start out by taking the absolute value of 3x plus 1, subtract negative 11, and I set that less than epsilon. Let's combine like terms. So we have 3x plus 12 has an absolute value less than epsilon. We can factor out the 3. So the absolute value of x plus 4 times 3 is less than epsilon. So the absolute value of x plus 4 is less than epsilon over 3. We need the absolute value of x subtract negative 4 is less than delta. But x subtract negative 4 and x plus 4 are the same thing. So we see that our proof will work as long as delta is less than or equal to epsilon over 3.